Afternoon, Year 4. Welcome to your first geography lesson on volcanoes. And we really enjoyed exploring earthquakes before half term and tectonic plate movements. So let's move on now to having a look at volcanoes. So our inquiry question today is, are all volcanoes the same? So as always, we're going to begin with our knowledge quiz. So either this will be completed on your task sheet, or you need to pause me now and number down 1 to 5 in your workbook. Okay, and welcome back. Let's go through the questions one by one. So if you've done it on your task sheet, that's great. You can mark it as we go along, or if you need to complete it now, remember to pause me after I say each of the questions. Question 1. What is the scale called that earthquakes are measured on? You have A, the rocking scale, B, magnitude scale, C, Richter scale, or D, the seismograph scale. Pause me now. Okay, and welcome back. Well done if you said it is the Richter scale. So the unit that we measure earthquakes in is magnitude. So we might say, for example, a 6.3 magnitude earthquake, but the actual scale that it's measured on is called the Richter scale. Question 2. What is the name of the earthquake drill that people should follow during an earthquake? Is it drop, cover, hold on, drop, hide, hold on, lay down, hold on, or run, hide, hold on? Pause me now. And welcome back. It is the first option, drop, cover, and hold on. So if you'll remember in our last lesson before half term, we looked at a school doing the drill, and the advice is drop, cover, and hold on. Question 3. More earthquakes occur on tectonic plate boundaries, true or false? Yes, so well done if you said that is true. At plate boundaries, more movement of the earth occurs and therefore more earthquakes happen. Going back to our last unit, circle all the items of jewellery that both the Celts and Romans had before the Roman invasion of Britain. Okay, let's have a look at the answers. So the two correct answers were torques and fibulas or fibula. Cloaks, they both had cloaks, but if we read the question, these aren't an item of jewellery. And dolphin rings, the Romans had these and they introduced them to the Celts in Britain. So the Celts did not have them before the Roman invasion. And question 5, if a river meanders, what is it doing? So is it absorbing rainwater, flowing in a straight line from its source, suddenly descending, which means going down, or slowly bending and turning its route? Pause me now and have a think back to year 3. Okay, and welcome back. So if a river is meandering, it's slowly bending and turning its route. So most rivers meander from their source rather than flowing in a straight line. So we've got 4 keywords for today, which are going to crop up quite a lot. Our first keyword is magma. Magma. So magma is molten rock which is under the ground. And our second keyword is lava. Lava. So lava is molten rock which is above the surface of the earth. So yes, they're very similar, but if it's under the ground, it's magma. If it's above the ground, it is lava. Our next keyword is vent. Vent. So the vent is the place where lava erupts from the volcano. And our last keyword is crater. Crater. So crater is the circular area at the top of the volcano. So pause me now and read through them again if you want to go over our keywords again. Okay, great. Let's begin the learning for today. So what is a volcano? A volcano is an opening in the Earth's surface through which magma rises from the mantle. So as you can see on this diagram, we have a magma chamber at the bottom. So if we think back to our key words, Magma is molten rock under the Earth's surface. And in the Earth, sometimes there is a vent in which the magma can come through. So I'd like you to pause me and have a think. At which plate boundaries are volcanoes more likely to occur? Pause me now and have a think. Okay, welcome back. So let's have a think about this together. So we've looked at transform plate boundaries quite a lot for earthquakes, where the two plates move past each other. But as there's no opening in the Earth's surface when there's a transform plate boundary movement, it's less likely that a volcano is going to occur here. So volcanoes are much more likely to occur either at divergent plate boundaries or convergent plate boundaries, because in this situation, in a divergent plate boundary, the plates pulling away from each other create an opportunity for magma to rise up. And in a convergent plate boundary, a plate going under the other one also creates an opportunity for magma to rise up. So as we can see here on our convergent plate boundary diagram, the plate going under creates an opportunity for a volcano, and it can also happen in a divergent plate boundary as well. So volcanoes usually occur at convergent plate boundaries. That's the most likely place that they happen. And they rarely occur at transform plate boundaries. There is little magma available there. So volcanoes usually occur at convergent plate boundaries, but they can also occur at divergent plate boundaries. Why do volcanoes erupt? So at a convergent plate boundary, one plate goes under the other, which allows magma to rise up from the mantle. And how do they erupt? So magma is pushed upwards through vents and craters. When this magma reaches the Earth's surface, it is known as lava. So as we said in our keywords, magma is molten rock under the ground. Lava is molten rock above the ground. So when it erupts, the magma is pushed upwards through the vents and the crater, and when it reaches the Earth's surface, it comes out as lava, and this is what we call a volcano erupting. After the eruption, there are many things that can happen. Lava gives off a large amount of gas, often resulting in an ash cloud, which is seen billowing out of the top of an erupting volcano. So billowing means that it's coming out and it's spreading around. So you're probably quite used to seeing images like the one we have here of a volcano. So as you can see, we have the crater, and then the lava giving off the gas can be seen in this very large ash cloud. So I'm going to have a quick recap. You don't need to write your answers down to this, but you can also if you want. So I'd just like you to shout the answer out. So which two plate boundaries do volcanoes form at? Yes, well done. If you said it's convergent and divergent plate boundaries, they do not usually form at transform plate boundaries. Second question. What is lava called before it reaches the Earth's surface? Excellent. It's called magma. So molten rock under the ground is magma, and above the ground it is lava. Now, there are three categories of volcanoes. We have active, dormant, and extinct. Just bear with me 1 second. So we have active volcanoes. An active volcano is one that is still erupting, or it's erupted very recently. So we're going to have actions for these words. So for active volcanoes, it's active. So we're going to be doing our physical activity. So follow me. Active. Active. Excellent, well done. Our second category of volcano is dormant. Dormant. So dormant is when a volcano hasn't erupted for a long time, but it's expected that maybe it might erupt again. So it's kind of like a sleeping volcano. So the verb dormir in French is to sleep, and in Latin. So we're going to do our action of sleeping volcanoes. So dormant. Dormant. Excellent, sleeping volcanoes, well done. And the third category of volcano is extinct. Extinct. So extinct is when a volcano is expected never to erupt again. It hasn't erupted for an extremely long time, so it's basically gone, it's dead. So for our action for extinct, we're going to say extinct. Extinct. Excellent, well done. So let's learn a little bit more about these three categories of volcanoes. Remember to do your actions when we go through them. So first of all, we have active. Show me your action. Very good. So active volcanoes are volcanoes that can erupt anytime and do so regularly. There are approximately 1,500 volcanoes that are active today, 75% of which are on the Ring of Fire, which we have looked at a lot during our earthquake topic. So we have an example here of an active volcano on, it's called Barron Volcano, and it's on Barron Island near India. So active volcanoes, they can erupt anytime and they do so regularly. So it's not always going to be a giant catastrophic explosion, but obviously every day there can be a little bit of movement, a little bit of lava perhaps, a bit of ash cloud, and they're expected to continue to erupt. So I will paste this link onto the home learning document, but there is a great map here where you can see all of the active volcanoes of the world and see when there's been an eruption or activity or a bit of unrest. So our second volcano was dormant. So show me your action for dormant. Excellent, well done. So a dormant volcano is a volcano that has not erupted recently, but there is a possibility it might erupt again. Now, by recently, I don't mean a week ago or a month ago or a year ago. Recently, in terms of volcanoes, is about 1 million years. So an example of a dormant volcano is a mountain called Kilimanjaro, which is in Tanzania in Africa. The last major eruption is believed to have been 150,000 to 200,000 years ago. So that's a really, really, really long time. But it's still not considered extinct because in terms of world history and the timeline of world history, it hasn't been not erupting for long enough to be classed as extinct yet. So let's have a look at extinct to try and compare what we mean by this. So extinct volcanoes, show me your action. Very good. So an extinct volcano is never expected to erupt again. To be classified as extinct, the volcano will usually not have erupted for over 1 million years. So if we go back to our dormant volcano in Mount Kilimanjaro, it hasn't erupted for 150,000 to 200,000 years. So that's a really long time, but it won't be able to be classed as extinct for another 800,000 years. So extinct volcanoes are extremely old. We have an example here of Mount Snowdon in Wales. Some of you might have been or you might have heard of it. And this has not erupted for about 500 million years. So that gives you a little bit of perspective. It's been an extremely long time since this volcano was active. So it's extinct. There's no expectation that it will ever erupt again. So before we move on, I'm just going to come back to the camera. Let's practice our actions one last time. So active. Oh, sorry, not that. Active. Well done. Dormant. And extinct. Excellent, well done. So I'm going to say the word, I want you to do the action. So dormant. Well done. Active. Dormant. Extinct. Active. Dormant. Well done, very good. And now shout out the word if I do an action. Well done, that's dormant. Active, well done, and extinct, very good. So those are the three categories of volcanoes that we can have. So for your first activity, I'd like you either to go to your task sheet where you've got written down numbers 1 to 4, or just jot down numbers 1 to 4 on your working paper. And we're going to play a game. So I'm going to show you a volcano and describe the volcano and its volcanic activity. And you're going to say whether it should be classified as active, dormant, or extinct. So first of all, let's look at an example together. So this isn't number 1, it's just your example. So here we have Mount Hood in Oregon, which is in America. Oregon's one of the 50 states. The last major eruption was in 1781 to 1782. And the latest minor eruptive event occurred in August 1907. So have a think. Do you think it's active, dormant, or extinct? So well done if you said it was dormant. So it's been over 100 years since the last eruption. There's not been a major eruption for about 250, 300 years. So it's classified as dormant, this volcano. So let's move on. I'm going to show you 4. I want you to say whether it should be classified as active, dormant, or extinct. First, we have Mount St. Helens, which is in Washington. So again, in America, Washington is one of the states, not to be confused with Washington, D.C. The last deadly eruption was 40 years ago, but it regularly erupts. So is it active, dormant, or extinct? Pause me now and write your answer down. Okay, and let's find out if you were right. It is active. Now, it's active because even though it's been 40 years since its last deadly eruption, it regularly erupts. So it's still active. So that's number 1. Number 2 is a volcano which is called the Nut, which is in Tasmania in Australia. So the Nut is over 13 million years old. It's mostly a solidified lava lake, and there are no explosions on record. So have a think. Is it active, dormant, or extinct? Pause me now. Welcome back. So the Nut in Australia is an extinct volcano. So there's no explosion on record, which means that we don't have any evidence that it's exploded any time since humans have been kind of around or documenting these things. And it's very old, and it's mostly just a solidified lump of what it used to be now. Number 3 is a volcano called Krakatoa in Indonesia. So an eruption in 1883 left the entire island barren. We have looked at the word barren before, actually, I think in our Vajak Poor topic. But the word barren means that it's empty of life. It killed everything on the island. The most recent explosion, however, was in 2012, so 9 years ago. So it hasn't had a very deadly or serious eruption since 1883, but it is still exploding, and its most recent explosion was 9 years ago. Pause me now. Is it active, dormant, or extinct? Well done if you said it is active. So it's exploded within the last 9 years, and there is volcanic activity occurring on it. Okay, number 4, our last one. I hope you're doing well. Our last one is a volcano called Oshima in Japan. The last detection of unrest was in 1996. That is about 25 years ago. But it last erupted in 1790. In 1741, an eruption created a tsunami which killed 1,500 people. So have a think about this one. There was a bit of unrest in 1996, but it hasn't actually erupted since 1790. Pause me now and write down if you think it's active, dormant, or extinct. Welcome back. Let's have a look. So well done if you said it is dormant. So even though there was some unrest 25 years ago, it hasn't exploded for about 300 years, and therefore it is classed as dormant. Well done. If you'd like to look up some more volcanoes, the Global Volcanism Project is a great place to start. So again, I'll put a link to this one on the home learning document, and you can search volcanoes based on lots of different criteria. So let's go back and have a quick review of our key inquiry question today. Are volcanoes all the same? Pause me now and just reflect on that in your head. Okay, welcome back. So we really should be saying that no, volcanoes aren't the same. Obviously, we've just looked at 3 different categories which they can fall into: active, dormant, and extinct. So there's already 3 ways that we can split volcanoes up and determine between them. And as you might have noticed from the 4 questions we just did and the example, They don't all look the same either. So let's have a think about why this might be. So again, just reflecting in your head, what differences can you notice between these two volcanoes? So don't just look at the fact that one has some fire and smoke. Have a look more at the shape and size of them. Pause me now and come back when you're ready. Okay, welcome back. So having a look at these volcanoes, we can see that they are actually really quite different. So they're different shapes to start off with. The one on the right here seems to be quite a bit sort of taller and it has a smaller peak at the top. And this one appears to be much wider. Another difference you might have noticed is that this one appears to be sort of a bit greenish still, perhaps have a bit of life on it, or at least the lava's kind of fallen in a certain way that it's dried to make it look like this, whereas this one is mostly just ash. It's very black. So there are three different types of volcano structures. We have composite, shield, and cone. So we are going to introduce three more actions for our lesson. So first of all, we have composite volcanoes. I'm just going to show you the action and then we will go over what these are. So composite volcanoes, our action is this. So to pretend like you're a volcano. So this is composite. Composite. Well done. Our next volcano is a shield volcano. Our action for shield is this. Shield. Shield. Well done. And our last volcano is cone. Now, cone ones are small, so we're just going to use our fingers to make a small volcano now. Cone. Cone. Very good. Well done. So let's find out about these three different types of volcanoes. So first of all, we have a composite volcano. So show me your action. Well done. So composite volcanoes obviously are that traditional kind of pointed volcano structure, and they're usually quite tall. We then have the shield volcano. So show me your shield action. Now our shield action, you might have noticed, doesn't look like how you might expect a volcano to look like, but that's because they are a lot flatter and wider. They're usually the biggest type of volcanoes. So we have our shield shape. And then the last one, as I said, we have the cone shape, which, yes, it does look a bit like a composite volcano, but it's on a much smaller scale. So this is our cone shaped volcano. So let's go back to the camera for a minute. I'm going to say a volcano name and you need to show me the action. So we're going to have shield. Well done. So shield are the wide and flat ones. Cone. Yep, cone is like this. It is pointy, but it is a lot smaller. And shield. Well done. I hope I caught you out there. And show me a composite volcano. So well done. Composite volcanoes are again pointy, but they are much bigger than a cone volcano. So here we have some real life examples. So Mount Fuji in Japan is a composite volcano. And also for a bit of extra information, it's an active volcano. Its last eruption was 1707, but there is activity being recorded. We then have Mauna Loa in Hawaii, which is the largest active volcano on the planet, and it is a shield volcano, which you might have got by seeing the size. So as you can see, it's massive, it's very, very wide, and it's very flat. So if you compare it to this picture of Mount Fuji compared to our volcano in Hawaii, this one is much flatter. And then an example of a cone volcano is Capulin volcano, which is in Mexico, which is actually an extinct volcano. But as you can see, yeah, it's kind of pointy. It's got a very large crater, but it's a lot smaller. It's a lot smaller than our other two volcanoes. So here it puts it into scale a little bit. So our shield volcano obviously is the biggest here, very wide and flat. We have the composite volcano, which is quite tall and pointy. And we have the cone volcano. So the cone volcano can sometimes also be called a cinder cone volcano. So it might be referred to on diagrams or things you read as either cone or cinder cone. But as we can see, it's a lot smaller than the other two volcanoes and it's still quite pointy. So why do these volcanoes look different? So let's have a look at our friend the composite volcano first of all. So show me your action. Excellent, well done. So a composite volcano erupts explosively. So it's a big eruption. They are usually quite large and cone shaped, and they are very steep as the lava does not flow far before it solidifies. So as we can see here, it's quite steep, the sides, which means they go up at quite a straight angle. And that's because when the lava flows from them, it doesn't flow very far. And obviously, once lava flows, it solidifies quite quickly into rock. So there we have our composite volcano. Shield volcanoes are gentler slopes and they have much runnier lava, which runs a long distance after they erupt. And that's why they are much wider in appearance and the slopes are not going as straight up. So the lava flows a lot further and that's why they are much wider, because obviously it solidifies going further out and it makes them look a lot wider. Eruptions are often slower and the lava splatters and bubbles rather than shoots forcefully into the air. So there is our shield volcano. And then we have our cone volcano or cinder cone volcano. So the cinder cone volcano has rock formed around the vent. So remembering our keyword, the vent is the place where the lava erupts from. So this area on the volcano here. They spew out cinder and hot ash. And some of these volcanoes smoke and erupt for a few years at a time. So they might not have a big eruption, but they might just be smoking or letting out a small amount of lava. Or not lava, sorry, more cinder and hot ash. You're most likely to find a cinder cone or cone volcano near other larger volcanoes, and they're relatively small in comparison, like our action shows. So coming back to our actions, composite volcanoes are shaped like this. They're much steeper. So steeper is when it's more like this than flat. And that's because the lava does not erupt. It's not runny, so it doesn't solidify very far down. So it solidifies and makes it quite a cone shape. The shield volcanoes are flatter and wider because the lava is runnier, which means it spreads out further. So when it solidifies, it forms more of this shape. And then our cone volcanoes are the much smaller ones. They're mostly producing hot ash and cinder, and they're usually found near other types of volcanoes. So if you would like to go back and watch those slides again, just to go over the different features of volcanoes, that would be great. So quick recap, we have our three main types: composite, shield, and cinder cone. So your second activity today, either on the worksheet or you can just do this in your book, is to write a description of each type of volcano using words from the word bank. So by each type, I mean composite, shield, and cone. So I know it's a bit confusing, so we're looking at lots of different ways we can describe volcanoes today, but put active, dormant, and extinct aside for 1 second, because that's kind of how we categorize them. But now we're just looking at our types of volcanoes, so composite, shield, and cone. So you just need to write a description about each of them. So I've put some keywords on here in my word bank, which I would love you to use. So I've color coded them. So the black words are to do with composite volcanoes. The red words are to do with shield volcanoes, and the orange words are to do with cone volcanoes. So have a look at the keywords and try and write a description of each one using these words. So if you feel confident and you'd like to go and do this independently, that's great. Pause me now and off you go. If you'd like a bit more support, I have an example of one that I've written about a composite volcano. Before you go as well, I'd just like to add a challenge. So can you give an example of each type of volcano and draw a diagram? So your challenge is to give me an example of each type, so composite, shield, and cone, which you could either look back on the slides, we went through one of each, or you could look on the database that I introduced you to earlier. And if you want to push yourself even further, can you draw a diagram of each type of volcano? So here's my example to do with composite volcanoes. So composite volcanoes erupt explosively. They are large and cone-shaped with steep sides due to the lava solidifying on the sides. An example of a composite volcano is Mount Fuji in Japan. So that is an example of what you can write about composite volcanoes. So go back to this now, pause me and have a go. Okay, welcome back. So let's answer our inquiry question together today. So if you would like to write an answer to this to post on Seashore to show your teacher, that's great. If not, you can just have a think and a reflection in your head. That's also fine. So we've looked at volcanoes today, and we've looked at 3 different categories they could be, either active, dormant, or extinct. And we've looked at 3 different types of volcanoes: composite, shield, and cone. So are volcanoes all the same? Well, I don't think volcanoes are all the same because they can be classified due to their activity, and they can all come in different shapes and sizes due to the different way that the magma and the lava behave. So, no, volcanoes are not all the same. So, I'd love to see your reflections and thoughts on this. But thank you for today's lesson. Let's quickly, one last time, go through our actions. So, first of all, show me an active volcano. Well done. Active, dormant, and extinct. Well done. And show me a composite volcano, a shield volcano, and a cone volcano. Excellent, well done. So your teachers and I cannot wait to see your work on Seesaw. I hope you've enjoyed the lesson. Have a good day, everyone.